Hello and welcome to the Postcard Professor, where we take complex ideas and explain them in the space of a postcard. In the last video, we set up a simulation of this plate with a hole in the middle. We created the geometry, set this fixed support constraint and a 1,000-pound load, and then we left the default material of structural steel and the default mesh. In this video, we're going to take a closer look at the mesh and see how it impacts the solution. And by that we mean the deformation, the stress, and the safety factor calculated for this part. Ideally, we get to a point where we change the mesh by refining it, and that no longer changes the solution. And we want that because this mesh is completely non-physical. It's just a translation from the reality we want to what the structural solver is able to understand. So as we go through this, we're going to be analyzing some data. So I'm going to start up Excel so we can record the information that we want. So to start, we're going to be changing up the resolution setting in the mesh. And then that will change the number of nodes and elements of our mesh. And so we'll record that. And then for each of these resolutions, we're also going to get the value for the maximum stress and the deformation. So those are kind of the two outputs that we can measure pretty well. And so all of that together should give us a pretty good picture of how well each of these meshes is performing. So ANSYS has 8 different settings for the mesh resolution, and so we'll have to do this quite a few times. To change the resolution, we click on the mesh in the outline, and then we find the resolution line down in the details. And you may have to open up the sizing tab in order to see the resolution. Now the default here is 2, and we can change that all the way down to 0. And then once we make that change, the color of the mesh changes, and we see that this is now an obsolete mesh. Now we can solve, and after we do so, we see that the mesh gets much coarser. To see the number of nodes and elements in the mesh, we're going to scroll down to the statistics section, then open that up, and we can see both nodes and elements in the mesh statistics. So the nodes are the points where the edges connect, and the elements are the actual volumes that make up the part. So once we have the nodes and elements, we can go get the maximum deformation and the maximum stress. And so you can see both of those just by clicking on the item in the outline, and then look at the color bar, which has the maximum value listed. You can also see the maximum and minimum value in the details section. All right, now that we know all these values, we'll write them down or go put them in Excel, and then we'll go to our next resolution. So for the next resolution, we'll just change the value to 1, and then go ahead and click the Solve button again. So once we get the values that we want, we'll go ahead and write those down or put them in Excel, and then we'll go off to our next resolution. So now that we know how to get all the data from our simulations, we can go take a look at the results. So from the resolution, you can see the progression on the number of elements and nodes, and also the change in deformation and stress. And so we can go ahead and plot these. And so if we look at these plots, we can see how the maximum deformation changes, right? It increases quite a bit at first, and then it levels off. And that leveling off is what we hope to see. And we see that also with the maximum stress, where we have quite a bit of change at the beginning, but then again, it starts to level off. And it doesn't quite get as clean as the maximum deformation does, but we can be pretty confident that it's somewhere in the 1.5 times 10 to the 8 range. And then you can see down for the number of nodes and elements that we do get a pretty steady increase. As long as we're looking at that at the y-axis logarithmically, right? So the y-axis should be a logarithmic progression, and we see that that stays pretty straight. So all of this was using the ANSYS resolution feature in order to perform a manual mesh convergence. What we're going to do next is perform an automatic mesh convergence. So to do automatic mesh convergence, first off, we need to create a convergence object. And we're going to do this under the result that we hope to converge. So the one that we had more trouble converging was the equivalent stress. So we're going to right click on equivalent stress, hover over insert, and then go down to convergence. We click that and it pulls up this convergence history tab. So we'll head to the mesh, reset our resolution to 2 as a decent baseline. Again, that is the default for ANSYS simulations. And then we can click solve. And what happens in this situation is we end up solving the problem twice. So we solve it once based off of that resolution 2 mesh. And then ANSYS uses that solution to target specific areas for a denser mesh. And if we look at our solution now, you'll see two things. First off, instead of having quadrilateral elements, now we have triangular faces here. So we have a different type of elements now. And then the second thing is we have a very slightly denser region around the hole than we do on this end, right? So ANSYS thinks that some areas are more important than others and will create more nodes, more elements in those regions. Now, it's possible to control how ANSYS does this a little bit, but the way that it does it by default actually works out pretty well for us. The only thing that we need to change is the allowable change option. So this is normally set to 20%. And what this means is that if we ever get less than 20% change in our maximum stress, then ANSYS is just going to say, we're done. We don't need to do anything else. But for this particular case, we want to be able to converge a little bit further, right? To see what happens if we keep converging. So we're going to change that allowable change to 0, right? And so this basically just says that no matter what we do, if I click the solve button, you're going to try to converge the solution further. Try to get rid of even more error. So ANSYS thinks that the solution is not converged anymore because the amount of change that we get, which is less than 1%, is still higher than the allowable change. So we press the solve button and we get another new mesh, and we can see even clearer for this new mesh that we have more nodes surrounding the hole, right? That is where ANSYS sees the most important thing to resolve. And then we can keep solving and add more and more elements to the mesh. As we keep solving, the mesh gets more converged, but it takes quite a bit of time. So the last solution that we do here actually ends up taking 4 minutes to do the convergence. But you see that there is a lot of resolution, especially in the area where we have that maximum convergence. So the last thing we want to take a look at is the comparison between manual and automatic convergence. So we can put all of the automatic convergence data into Excel as well, and just plot the maximum stress based off of the number of nodes or the number of elements. And in either situation, we can see that the automatic convergence ends up with a lot more nodes and elements than you get with the manual convergence. And so that's the biggest thing that is providing us with additional accuracy. The other really nice thing about the automatic convergence is that the pathway to convergence is a lot more predictable. It's a smooth decline towards that maximum stress that we expect. And so it's much easier to see how close to converged we are than the manual convergence, which is kind of jumping all over the place. So in general, the automatic convergence is more convenient, right? We don't have to manually go in and change the resolution. It's also more effective. But we will run into some problems later where the automatic convergence creates what we call stress concentrations. And these sometimes are physical, right? Around the circle, the hole in our mesh, there was a physical stress concentration. But in some circumstances, we get stress concentrations that are not physical, and we'll have to learn how to avoid those. So we will run into those later, but we'll take care of those as they show up.